Hello, this is CIT 371, Linux System Administration, and we're going to cover OpenLDAP implementation. So, I provided an OpenLDAP module in this course because I wanted to go over some topics on directories and LDAP, directory structure and LDAP. I'm also going to talk about the OpenLDAP implementation lab. For that lab, we're going to work with a Dockerized or a containerized version of OpenLDAP. So more of the focus on this module is to understand how directories work. So you may be asking, what is a directory? So a directory is a data structure that is used to store information that pertains to an organization's users, computers, groups, and other resources. This is going to include printers. You can put in printers in Active Directory and some other resources. So directories are also called directory services, LDAP directories, or user stores. So think of it is when you look up articles on the internet about a directory or directories, you'll find different terminology used to talk about them. So just to let you know when you do research on the topic. Now directories are used in organizations to manage users' ability to access resources, store their important data, and allow applications to access this data as needed. So a directory is often compared to a database. Some articles will actually use the two terms interchangeably, but that really isn't accurate, and here's why. Directories have a hierarchical or tree-based structure. Databases use a relational or tabular structure, so the way everything's organized is very different. The directories, kind of like the Linux file system, have a root, and then they build up from there, like in branches, like a tree. Databases are more based or organized like have a tabular structure, where tables relate to information in tables relate to one another. Now directories allow for faster queries, and databases will provide quicker editing times. So there's pluses and minuses to both, but directories are better suited for especially with user permissions and stuff like that, and groups and user permissions. The hierarchical nature of directories is better used for that kind of information. So we're going to talk about the data in directories now. Directories are typically used to store the following kind of data. Data that fix these characteristics. So the data in directories is usually descriptive. It records multiple attributes about a user or device. An example would be like first and last name, email, sometimes phone number, and group permissions and so forth. Static. This information is static. Stores information about user devices that never or rarely changes. So, for example, somebody's name isn't going to change very often, or if ever. A person's phone number is typically going to be pretty static. Group permissions do change a little more, but once they're changed, they typically stay that way for a long time. Kind of one big part of my job at NKU is putting people in different putting people in the right group to access file resources. And yeah, that changes. Once that change is made, it kind of stays for a long time, unless a person changes department or leaves the university. And then finally, directories store valuable data. I will note that data in directories is often sensitive and crucial to a company's ability to function. So it's important to secure your directory. So yeah, as I was saying, all the information here, like full names, home addresses, usernames, email addresses, passwords, job title, department, group membership, and account permissions and preferences. All these fit the kind of description of data that would go in a directory. This data that is descriptive of a user, it doesn't change very often, and it is valuable. So directory components. So directories are comprised of the following components. There's the attribute component. Now this is similar to key value pairs. Attributes store data belonging to a specific entry. The following consists of common attributes. So the CN attribute stands for common name. This is typically like the first and last name of a person. For example, in a directory, CN equals John Doe would mean this value for this user is storing the first and last name, John Doe. OU is organizational unit, which is a container in a directory that's used to store specific users, groups, or computers. For example, if you took CIT 271, you'll note that different departments have their own OU, organizational unit. It's kind of like a folder. So, for example, if you have a help desk and you want to put users in there and manage their permissions from the OU, you put them in this. You put a bunch of users in an organization unit with that name of the department. help with sorting. Now in CIT 271, we also used organizational units for creating, let's see, what was it, group policies that affected certain users. And the thing of it is that those group policies affect people by the organizational unit they're in. So that's why these folders are important. Now the C by itself just is reserved for country, like the US or the UK. And DC is domain component. Now this specifies a company's domain. This is where it typically serves as the DIT root. So for example, it's basically part of the root of the website name or URL. So like DC equals NQU, DC equals edu is .nqu.edu and your website. Directories also have entries or objects. Now, one of these two mean or refer to a collection of attributes associated with a specific user, device, or other entity defined in a directory. Now, an object would be like a user account. And a user account, when you look in Active Directory, for example, you open up a user account, you can look up all this information about the user, like his or her name, address, group permissions, and so forth. Finally, there are data information trees, also called directory information trees. These provide the hierarchical placement of data in a directory. This is represented with the following. So there's the distinguished name, which lists the full path of an object in the DIT root, and the relative distinguished name, or RN, which is one or more components of the DN, or domain, or distinguished name. I'm going to give an example of that in this little picture here. So at the top we have NQ edu, so that's .nq.edu. This is the root of NQ's directory, let's say. Now let's say we have these OUs. By the way, this is not how NQ is structured at all. I work here and I can tell you for a fact that we don't have OUs like this. It's quite a bit different. But anyway, so let's say we have three OUs. We have the IT OU for IT users, we have the OU for students, and we have OU for faculty. So say we want to pull up my friend Brad Thomas in the directory. One is DN. So his full path in the directory, this is a very short example, is CN equals Brad Thomas. That's his full name, and that's how he's represented with the common name. OU equals faculty. That's the faculty folder or direct OU he's in, organizational unit, and then that is near the root of DC NQ.edu. So if we want to query, or if we want to specify Brad Thomas with an LDAP string, we have to use this DN here. We have to use this full path. Now here's me. If you want to know the example with me, we have to pull up CN equals Tyler Poe, then OU IT, with me being an IT, and then DC equals NQ, DC equals edu. So basically the C name, or CN here, would be replaced with my name. So we could say like Brad Thomas, if we want to look him up, we can find information on his email address, his telephone number, department, office location, and password. Well, the password you probably wouldn't find, but that's the object here would store that. Thing of it is we want an RDN, we can pull, if we want a relative path, like we're starting from faculty, we can get his mail address, Brad's mail address, and it'll be connected to Brad Thomas and then faculty. So directory to components now. Directories are defined by specifying the name and metadata of attributes. Because this task is rather complicated and requires an understanding of attribute metadata, most LDAP implementations come with predefined attributes. Attributes are then grouped together in object classes to help define certain objects. For example, the organizational unit people would be used to define users. Attribute and object class definitions are then grouped together in schemas. A single DIT typically has many schemas that define and store entries and their attributes. There's a Digital Oceans article and a references slide I've added that will provide some good information on all this. So we've talked a lot about directories, but what is LDAP? What does LDAP have to do with this? So LDAP is the Lightweight Directory Access Protocol. So as the name implies, it's a protocol used to access directory information. It can allow you to request it and retrieve it quickly. I should note that LDAP is not the directory itself. Now, people do get that confused, and even on a lot of tech articles, people call the directory LDAP. That is not correct. LDAP is nothing more than a protocol that is used to access and interact with the data in the directory. LDAP is not the directory itself, but is the means by which you access information in the directory. So LDAP supports the following actions working with directories. There's adding, to insert new data or files into the directory. You can delete data, you can search for it, you can compare two files to find their similarities and differences, and then you can modify existing data in the directory. So the LDAP process starts with an application needing data about a user. It's typically username or password authentication. A session connection then occurs where the user connects to the LDAP server via the appropriate port. 389 is unencrypted, 636 is encrypted. We typically want to use the latter. A request is then made via the query which specifies requests specific data from the server. So after this, the LDAP protocol sends the response by running the query on the directory from the server, retrieves the information the client wants, and then sends it to the user. When the required data is received on the user side, the connection to the LDAP server is closed. So I talked a lot about directory tools, including Active Directory, and that's because, even in places that rely on a lot of Linux, some are willing to shell out enough money to use Active Directory. The thing of it is, it's a lot easier to use than OpenLDAP. It provides a GUI interface. It's very convenient. Active Directory is really good, and if you've used it, if you've had experience with it, you've probably seen it in CIT 271. But Linux uses, if you're relying on Linux, and you want to say completely open source and not pay for Windows licensing, you have to turn to a solution like OpenLDAP. This is an open source tool that allows you to use a Linux device as an LDAP server. It is managed with terminal commands and ILDIF files. Some implementations of OpenLDAP, if you look, do come with a GUI, and they're pretty cool. While other tools are available, Active Directory is by far the most commonly used for for working with directories. If you work in a heavy Linux environment that makes heavy use of open source software, you might encounter OpenLDAP. Now, I know OpenLDAP is going to be a lot less common than Active Directory. You may never see OpenLDAP in your life. The thing of it is, I do want to cover it here because OpenLDAP, working with it gives you a better understanding of how LDAP works. Active Directory hides a lot of that with the GUI, but OpenLDAP, you're actually digging in the weeds a lot more, and it's better for learning how directories work, and that's why I want to cover in this class. But anyway, lab overview. So this last lab here, for this one lab here, OpenLDAP implementation, you're going to implement this software in a Docker container. You're going to be provided an article from Medium to guide you. Now, this is going to be the most guided lab in this course, because this is pretty easy to mess up, and unfortunately, this article is the only one I could really find that was the easiest to follow for setting up OpenLDAP, and yet it does contain errors. I please caution you to pay very close attention to the lab instruction document you're going to download, and you're going to need to deviate from this Medium article as you're advised, because if you don't, this isn't going to work. Now, I will say, if you make a mistake with your OpenLDAP implementation, you're probably just going to need to delete and recreate the container and start from scratch. The reason being, fixing this is almost impossible. If you make a mistake in these files, you got to start over. So make sure you follow everything as closely as possible to let you do this in one run. I do want to recommend you to record your configurations as you go through the lab, so you can easily re-add them if you delete and recreate your container. Like, you can put them in like text files, for example, if you want to save them for easy copy and paste. And this lab used a lot of different resources. I've included them here in a referencing slide. If you want to learn more about LDAP, definitely can recommend these resources here. But anyway, I'm really very thankful for your time watching this lecture and the others. Hope they were very helpful, and I hope you have a good day.